Hello everyone, I'm Xinya, a staff backend engineer from AI Framework Group. Today I'd like to demonstrate a really cool feature. Um, this one, tracing with LangSmith. So tracing is a powerful tool for understanding the behavior of your LLM application. LangSmith has best-in-class tracing capabilities, and it's integrated with GitLab DuoChat. Tracing can help you track down issues like, I'm new to GitLab DuoChat and I would like to understand what's going on under the hood, where exactly the process failed, when you got an unexpected answer, which process was bottleneck of the latency, what tool was used for an ambiguous question. So over the time, we are trying to improve the quality of dual chat. However, there are always like challenges because of lacking observability. We have no idea what's going on under the hood, and then spending significant time on the investigation. And then as of today, what we have is only logs, which is this LLM log. This is pretty helpful to, for example, get the what prompt was executed in a single dual chat call. However, it's kind of point-to-point data that like it doesn't give you a holistic picture. So this is a reason why we introduced this tracing with LangSmith. So I'd like to demonstrate 3 use cases today. One is when you wanna understand what's going on, like you let's say you are assigned a tuna issue to investigate the like problematic behavior, and you want to understand what's going on under the hood. The second is running trace with evaluation. We're going to use prompt library as a single source of truth evaluation framework. And at the last, we're going to use tracing with RSpec. As a predecessor, we used to use RSpec testing for quality assessment, and then let's see if we can use that. So first of all, I'm gonna demonstrate how it works. So let's say here's my GDK. It's running on my local computer, and I'm at this one of the issues. And then I'm going to ask a question like at first, let's screen. Now my chat history is screened, and I'm gonna ask, summarize this question, summarize this issue. Now this request has been sent to GitLab Rails, and then it's processed in Sidekick and blah blah blah. But like, as I'm trying to demonstrate as if I'm completely new to DuoChat, so like I have no idea about like these things. So here's the answer. This close issue is about updating the work item DLP to add a work item type icon. It seems orthogonal to this the actual description. So it seems okay. Now, if we look at that access to this LangSmith web console, by the way, I already enabled LangSmith integration via this section, via this setting. It's pretty easy. First, you have access to LangSmith site and create an account and create the API key, the set the environment variables, these things inside your GDK. I recommend setting it in and run it. But it's pretty easy. You can just set up in 3 minutes. And then now this is what I'm seeing under the hood. So first, running a duo chat. Here's a question. I'm seeing that what I passed to the duo chat prompt, duo chat window. And then here, the first React framework, React execution is performed. This is also known as the zero-shot executor class. But yeah, so this is basically like a chain of thought process that try to reasoning and thinking about what's the next action of until it reaching the final answer. So the first, it building a prompt and then requesting to AI Gateway. AI Gateway is our service to resolve LLM call. So basically, you can just read it as a request to Anthropic in this case, to get an answer from response. And then the next one is calling issue reader tool. And so here's quite interesting because we asked summarize this issue. We can kind of guess that this issue should be this issue number 416800. So at some points in this process chain, some tool needs to fetch the information. So we can see that issue reader tool was selected in this React prompt, and then requesting the A gateway. And here is a resource identification. So under this tool, we can see that issue ID 416800 was correctly fetched. So it seems going okay. And the next, with this fetched resource, it's duo chat trying to generate the final answer, and then request to AI gateway. By the way, you can see the full prompt in this input keyword. Input contains all of the information that was needed to generate the output. So of course, it includes prompt, also like parameters, model names, or any like variables that was necessarily for this class and method execution. Then we can dig into prompt details, but since this is successful run, I won't go into it. And then here's output. Let's see. Output's quite interesting. So let me show you the detail. Okay. Here's an output from the last LLM call. Based on the issue details, this issue extracted. This issue is about about points 1 to 3. It was created, and here's a sum of the information. I have summarized the key details about this issue. So final answer keyword. This is part of the chain of thought React concept that like if the chain of thought reaches the final answer, then it should prefixed with this final answer, this one. And then here, disclose issues about updating, blah, blah, blah. This is actually what you saw in the duo chat window. So what was used actually, this part only, meaning get answer from response. This is a parser. This parsing step is this parsing step got the raw output from LLM, and then parse only important part, which is final. In this case, yeah. So here's a parse response. So all of the unnecessary information above were stripped. So here is a example use case. Fortunately, this run succeeded, but actually, my previous attempt was previous attempt failed. So let me show you why it failed, how it could happen. For example, this is exactly the same question I asked like this UI, and then yeah, the question is exactly the same. Summarize this issue. And then we can see that same process happened at the first building prompt, the building the initial React prompt and throwing to LLM, and I get answer. Then LLM said you should use issue reader tool. So like now constructing prompt for issue reader and requesting to LLM again, and then identifying the resource for the same issue was returned until this line that was exactly the same. However, if we see this at the last step to generate the response, let's see, here's output. This looks similar to the previous one. However, yeah, it's kind of like a simple information. The final answer is looks pretty okay. This close issue was updated, blah blah blah. And however, there's a bit of weird thingy at the last. The question: what is the current state of the issue? So this is unexpected. Hence, user sees that. Let's see. The final output. This is the final output. I'm gonna parse it. Okay. So summary was fine. However, there is a noise here. Question: what is the current state of the issue? This isn't supposed to be returned. This shouldn't be appear in this window, this GeoChat window at all. Then why this question was included? That's a next question, right? And then we can see that so first of all, LLM return included this question. So this is where something started going wrong. But since LLM can hallucinate sometimes, this is kind of understandable. Like it should be handled at the application side. We can just blame LLM. And then like if we look at the parser, here's the last parser side, and I'm going to the class. Oops, this is different project. There you go. We are seeing that the method is from response, right? This is a class name, method is from response. Yeah, from response, chain of thought parser. Something went wrong in this method, because like if parser works finally, it should strip that question line. However, if parser failed strip question, then let's see, like the from response here is a chain of thought parser, and then parse final answer, and the final answer. Here's a, if you look at this regex, you can see that there's a /m. So this means like all content after this final answer should be final answer. This M meaning including new lines. So this also include this part as well. So that's one of the issues here. Probably the culprit. So like we can at least have more clear idea like where to fix if like something went wrong, like in this case. So that's a power of Tracer. So I highly recommend you try using it out. So it took quite a long time, but let's going through the evaluation case. What I wanted to demonstrate at the second. So evaluation is quite important lately. That let's say you are assigned to our the quality improvement issue, like your chat is performing badly on some let's say issue or epic, and then you need to generate a score of a proposed fix. And now in that case, what we're going to do is like running a prompt library, which is provided by model evaluation team. And then you run a CLI like this. This is a prompt library dual chat evaluation. Config file is this defines the input data set and output data set. I'm not going to details of the evaluation framework, but what I wanted to emphasize that you should run Tracer with evaluation library, evaluation tools, because here's an example output of evaluation library. For example, here's input data set. There are 3 questions, summarize this issue. And then there are 3 resource URL, different resources. Then here's our answer from TioChat. Summarize this issue. And then here's answer 1, answer 2, answer 3, and then you see also correctness, readability, comprehensiveness scores. All look nice because like this grade score is the range is between 0 to 4, so 4 is the highest. And then quite frankly, if you look at that response, it looks okay. Yeah, so the overall like this evaluation seems not problematic at all. However, you can, if you see Tracer, you can get more idea of it. Let's for example, like these 3 rows are corresponding to these 3 evaluation runs, and then if you look at the first run, like this is a summarized issue, and then the resource is specified, issue ID something. And the interesting thing is that let's take a look at the second one. This is what you saw earlier. Run React, build a prompt, throwing the initial React prompt, and then throwing the picking up the issue reader tool, and then request to AI gateway at the second. And then the third one is generating final answer. So there are 3 steps needed in general. However, if you look at that first one, it doesn't have issue reader at all. This is quite interesting because it directly giving a direct answer. If you look at this, request to AI gateway, checking out the output. Let's see. This is output. This usually contains detailed information about the research and something. It seems that to summarize the key findings, action, direct answer, the final answer. Final answer is already returned, even though we didn't execute issue reader tool at all. Why this happens? The answer is actually probably inside the prompt. If you look at this, let's say this is a prompt that was thrown to, this is the initial React prompt, okay, to LLM. And then let's sanitize a bit to understand the question. Here's a prompt. What do we pass to LLM? And we can see that human prefix, here's some instruction to the LLM. You should behave like blah, blah, blah. And answer the question accurately as you can. You have access only to the following tools. So here, this is a React prompt because it giving LLM a bunch of tools, like you can use C tools, issue reader tool. One of them is issue reader tool. So yeah, LLM is supposed to pick up the issue reader tool, but it didn't. Then now if you scroll down a bit, the tool is ended. And then this still instructions going on. Here's our structured output, because it uses React, question, thought, action, input, observation, thought, and then final answer. These are still instruction. And then if it's you have actual the user. Okay. So here's the interesting part. We are instructing LLM that like please pick up a tool for answering users' question, but also we are passing to LLM that environmental information that where the user is at right now. And for example, the user is currently on a page that shows an issue which has a description, comments, etc., which the user might reference example as current this, that. Here's additional data resource tags about the resource that user is working with. So in dual chat, we are passing the information of where user at right now, which is serialized information of this issue by default from the beginning. So the resource details is all included here. The resource is fetched, and then question summarize the issue. Now, if you think about like pretend like you are LLM, since you already seen that this issue, you already seeing this issue information, you don't need to pick up the issue reader tool at all, right? Because you already have the information of this. So if you are asked to summarize the issue, you just summarize this resource tag, resource section. So that means like what we saw the other example, other one, like picking up the issue reader tool, is quite redundant because it's fetching exactly the same information twice and then stuffing the duplicated information. So if you look at the this prompt, the final prompt, you can see that this resource, where is it? Resource, yeah, this resource tag, it's stuffed twice, which is could be problematic in the future. And more importantly, it's slower because each LLM code takes significant time. This one is 26 seconds. It's quite long. So less LLM code is definitely more preferable. And in this case, we are fetching that, redundant steps. So that's something we can optimize in the future. So this is what I wanted to demonstrate at the second. And at the last, this is a quick walkthrough, but you can also run tracing with RSpec. So RSpec is we have this GitLab Duo Chat QA job, and then you can manually execute in pipeline. So when you author a new merge request, let's see. yeah, when you write up a new module request and you wanna run evaluation with this predecessor, the GitLab Duo Chat QA, and they run the bunch of this job actually runs quite a nice coverage of test cases. Yeah, for example, these test cases are going to run, which is quite nice. But also like I demonstrated with a prompt library, this doesn't give you any information about what happened under the hood. It gives you like the final answer and the grade, which is helpful to understand the overall performance. But like when it's something went wrong, it doesn't give you a visibility to dig into more details. Now, you can do the similar thing with what I demonstrated with prompt library by going to GitLab Duo Chat QA, and then if this manual job, there's already interface to set the environment variables. This is a retry case, so I'm going to go this page. So this job requires manual action, and there's some form to set environment variables. So you can set these variables. Go LangChain, that's true. LangChain API key, this is your secret LangChain project. I don't know, RSpec demo or something. Yeah, something like that. And then you can set these environment variables and then run job again. And then you should be able to see the same traces alongside that this overview, score overview. So that's all I wanted to demonstrate today. Please let me know if you have any questions, and then let me know. I'm gonna put a link in this video about this, how to set up the LangSmith integration. So yeah, try it out, and then please let me know what do you think. Thank you.